Now let's discuss about the demineralization, deionization and desalination. So what is the basic difference between demineralization, deionization and desalination? Demineralization is a process utilizing special manufacturing ion exchange resin which remove ionized salt from the water, right? It thoroughly remove 100% of salt. Deionization typically does not remove organic and viruses and various bacteria, right? But accidentally it can remove trapping by the resins. Accidentally, if it's trapping by the resins and specially made from the strong base anion resin, which will remove gram negative bacteria. Another possible process to create deionized water is the electrodialysis. Now, what is meaning of demineralization? Demineralization is a often term usually interchange with the deionization, but demineralization is essentially removal all the minerals that can be found in nature water, right? So in deionization we are removing 100% salt, where in demineralization we are removing only natural particle or natural salt which are present in natural water, or we are removing just minerals from the natural water. So it is difficult to differentiate between deionization and demineralization. There is no standard definition for the differentiating deionization and demineralization, but from the some reference we can say that if a particular method remove 100% salt, then it's known as a deionization, and a particular system or particular treatment remove minerals which found in natural water, then it's known as a demineralization. Demineralization is a process is usually done when the water will be used for the chemical process and minerals present may be interfere with the other chemical. All chemist and beauty product have to be made with the demineralization water for the this reason. Now, what is meaning of desalination? Desalination is the process of removing salt or other minerals and contaminant from the seawater or brackish water and wastewater effluent, and it is increasingly common solution to obtain fresh water for the human consumption and for the domestic and industrial utilization. So in desalination we are just removing salt and all the other contaminant from the seawater. From the its name suggests desalination, so we are using seawater or brackish water to remove the minerals and contaminant, right? So it is easy to differentiate between between the deionization, demineralization and compare with the desalination, but it is difficult to differentiate between deionization and demineralization. We can easily differentiate demineralization and desalination, or we can easily differentiate between deionization and desalination, but it is difficult to differentiate between deionization and demineralization, right? There is no standard definition for the differentiation between the deionization and demineralization. Mostly demineralization, deionization, right? Demineralization, deionization and desalination is done by three main routes. One which is from the ion exchange, second one from the electrodialysis, and third one from the membrane filtration. So there are various methods which used for the ion exchange, or which used for the demineralization, deionization and desalination, right? But we are going to mainly focus on ion exchange process, electrodeionization or electrodialysis, and membrane filtration. From membrane filtration we are just focused on reverse osmosis. In electrodeionization we mostly focus on electrodialysis and ion exchange process, right? So let's first discuss about the ion exchange process. Deionization entails removal of electric charge of ion or ionized dissolved substance by the binding them to positive or negative charge site on resins as water pass through the column packed with this resin. This process known as a ion exchange and can be used in different way to produce deionized water in various quality, right? So there will be a three main route for the ion exchange process. One, which is a strong acid cation and strong base ionization. Second one, which is a strong acid cation, weak base anion and strong base ionization system. And third one, which is a mixed bed deionization, which made from strong acid, strong base, weak base, and this both systems, right? So let's first discuss about the strong acid cation and strong base anion system. So this figure is show the strong acid cation plus strong base anion resin system. This system consists of two vessel, one vessel containing cation exchange resin, right? So this vessel is consist of strong acid cation resins, where second system which consists strong base anion resin, right? So this system consists of two vessel, one contain a cation exchange resin in the hydrogen form, right, for the hydrogen form, and other containing anion resin in a hydroxyl form which known as a OH minus, right? So we can use this type of system for the purification of water. Water is flow from water is flow through the cation column, right? So raw water which contain CaHCO3, MgHCO3, CaSO4, MgSO4, CaCl2, NaCl2. So it's contain hard water and soft water contaminant, right, which flow through the cation column, whereupon all the cation are exchanged for the hydrogen ion. The decationization water then flow through the anion column. This time all the negative charge ion are exchanged from the hydroxide ion, which then combine with the hydrogen ion to form a water. This system remove all ions including silica. In the majority of case, it is advisable to reduce the flux of ion passed to the anion exchanger by installing a CO2 removal unit between the ion exchange vessel. This reduces the CO2 content to a few milligram per liter and bring about a reduction of following strong base anion resin volume and generation of regeneration and which require the regeneration, right? So it is required to remove the CO2 for the regeneration of the resins. Now let's discuss about the second system, which is known as a strong acid cation, weak base anion and strong base anion resin system. This combination is a variation of the previous one, right, or this is a modification of the previous one. It provides same quantity of deionized water while offering economical advantage when treating the water with the which contain high load and strong anions, right? The subtitles show that the system is equipped with the extra weak base anion exchange before the final strong anion exchange. The optional CO2 removal unit may be installed either after cation exchanger or between two anion exchanger, right? So here we can use the CO2 removal unit as per the requirement. We can use either here or we can use either here. So this is the schematic representation of the strong acid cation, weak base anion and strong base anion resin system. The regeneration of anion exchanger take place with caustic soda, right? So we can regenerate the resin using the NaOH. right? Caustic soda are mostly used to regeneration of anion resin solution, right? So we are just going to pass caustic soda solution, passing first from the strong base resin and through the weak base resin. This method require less caustic soda than the method described the previous one, right? Here for this method, we require higher amount of NOH for regeneration of this anion resin compared to the this method, right? However, when a raw water contain a high proportion of organic matter, the weak base resin protect the strong base resin, right? So this is about the strong acid cation, weak base ion and strong base ion. Now let's discuss about the mixed bed deionization. In mixed bed deionization, the cation exchange and anion exchange resin are intermediately mixed and contaminated in single pressure vessel. The two resins are mixed by the agitation with the compressed air so that whole bed can be regarded as an infinite number of anion and cation exchanger in series. To carry out regeneration, the two resins are separate hydraulically during the losing the phase. As the anion result in lighter than the cation resin, it rises to a top, right? So here, as shown in figure, we are anion bed are the upper at top part from the cation bed, right? So this is a figure for the mixed bed deionization in which anion bed and cation bed are mixed with the each other. At upper part there is a anion bed and at lower part there is a cation bed. So what is the advantages and disadvantages of the ion exchange process? Ion exchange process like reverse osmosis, it can be used with the fluctuating flow rate, right? We can use of fluctuate flow rate for this process. Effluent contamination is impossible in this method. Large variety of specific resins are available from supplier. Each resin is effective in removal of a specific contamination, right? And what are the various limitations for the ion exchange? Ion exchange waste is a highly concentrated and require careful disposal, right? So there is a problem with the discharge of waste in this type of method. Then second one is the potential for the unacceptable level peaks or contaminant in effluent. Usually not feasible with the high level of TDS. We cannot use this method for the high level TDS, and pre-treatment are required for the surface water. If we are going to use the surface water, we require the sand filter and then the clarification and then other process. Then after we can go for the ion exchange process. So we require pre-filtration process for the ion exchange process. So these all are limitation for the ion exchange process.